Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome everybody again to another episode of our show, bringing another really awesome guest today involved in science and technology, creating a better tomorrow for everybody out there. Today on the show, we have the honor of being joined by Dr. Adnan Masood, who is the Chief Artificial Intelligence Architect at UST, which is the giant digital transformation solutions company. And Dr. Masood brings over 2 decades of leadership experience in artificial intelligence, in machine learning, and large-scale systems architecture, is ultimately bridging cutting-edge academic research with very real-world business applications. At UST, Dr. Masood leads the firm's global strategy for cognitive computing, AI, machine learning, and generative AI initiatives. He oversees the development of various scalable data integration platforms, high-performance recommendation systems, enterprise-grade AI, and at the same time is involved in fostering collaborations with various elite research universities, including Stanford Artificial Intelligence Laboratory, MIT Computer Science and AI Laboratory. Before this current role, Dr. Masood's experience spanned financial services technology, startup, systems architecture, cloud native engineering, ultimately, with the core research mindset focused on machine learning. He was recognized as a Microsoft regional director and a Microsoft MVP for artificial intelligence. And he is not only a practitioner, but a very important thought leader and educator, and has taught data science and spoke at various international conferences, authored best-selling books on programming and AI governance. And in this current role at UST has been really instrumental in shaping the company's whole AI Center of Excellence model, ultimately guiding clients to ultimately building these novel systems, leading cross-functional teams. A lot to get into today, a lot of really cool topics. An honor to have him. Dr. Adnan Masood, thank you so much for taking time to come on the show today.
Thank you very much, Ira. It's glad to be here, and thank you for the kind introduction. Sounds great.
Yeah, it's an amazing journey you've been on. I'm going to like going into a lot of these themes. But before we go anywhere near UST and what you're doing now, would love to sort of start off at the beginning. Sort of everything from where you started off, how you got in, sort of just into AI and programming in general, and if we could sort of go up to maybe 2014 in your dissertation, because it is, it's interesting in your dissertation. It's at this point where you introduce a concept of interestingness and the ability to look at data points, analyze if they're interesting and worth investigating or not, which is not just cool in its own right, but sort of forms the basis for a lot of what you do afterwards. And so take us back a bit, if you would, and give us a little bit of the introduction in this time span.
Sure, we can do a time travel journey. It's very apt, providing we are talking about quantum computing today. So I guess, so my interest has always been in artificial intelligence and machine learning, specifically mainly because of their predictive capabilities, but now, of course, with the generative capabilities as well. And when I started looking into outlier analysis and anomaly detection, so looking into how things represent themselves as outliers, what are the true definitions of outliers, what is noise and what are the meaningful outliers. That is the key distinction you have to make in terms of interestingness, right? A quality which makes something capture and hold attention as compared to the noise, right? And what sparks curiosity, surprise, emotional engagement. These are really important qualities and attributes and features within a data set. But it's very easy to ignore them as noise. You can see sometimes outliers, which are financial transactions which are above a certain threshold, or financial transactions which are happening somewhere in a faraway city where you have never visited, and you see that happening with over a certain threshold, and that's a fraud alert. But that is what interestingness is all about, like how you capture and something which is sparks the curiosity is a way different from your typical trend of uh, how you spend money, for that matter, right? And it is, think of it as a novelty, unexpected connection, how this hold the relevance and insight into your work. And that's essentially what brought me to defining interestingness as a measure for outliers and anomalies. I think that's more of a Eli Fire style, a simplistic overview of the research part of it. And then you dive into how you can formally define interestingness, and how you can formally define interestingness on large scale data sets so it can be practical and used for enterprise use cases. So that was what my dissertation was essentially about. How can we define interestingness which is beyond just a distance measure? So this is like your point, and it's this much far away. So that is what's an outlier or anomaly is. And is that anomaly interesting or not? What measures can you put in place to quantitatively analyze that, along with the qualitative attributes to see if that is an interesting and again, it's a lot of subjective elements to it. In different use cases, in different industries, in different domains, the interestingness can be defined in different manners. So it's a fairly interesting area, and it's actually something which is happening now. We are seeing that happening in generative AI and AI machine learning in general, to see how we can detect hallucinations and figure out how those could be real true hallucinations versus creative outputs based on temperature. So yeah, that's where the journey started. And since then, I've been involved in working with the Stanford AI Lab and MIT on behalf of UST, working with various research institutes in that space, publishing papers. I've moved now more towards large language models and been working on LLMs for a while, but that was my original approach.
And you know, in parallel to that, another term I just like to introduce for our audience, because we don't hear about it too much, but obviously this is another important part of sort of what you've been doing, and sort of how you think of, you know, taking things like what we were just talking about in terms of interestingness and ultimately operationalizing them for various clients and companies over the years. But could you introduce just the principle of what a cognitive service means in terms of some of sort of the pre-built artificial intelligence tools that you are developing for your clients?
Right. So I think cognitive service is a very broad term. I actually wrote a book about it. I think you are referring to that in terms of, so we used to call the web services, as you know, web services are essentially the services which are provided. So it's very not much different from different type of services which an enterprise will provide to their customer to do certain tools and tasks. So you can have capabilities to maybe connect to a compute cloud. You may have capability to store something. You may have capability to do certain jobs, long-running processes, compute, storage, processing of things. So these are the typical web services or APIs you have available. Now, when it comes to cognitive computing, when it comes to intelligence, when you are trying to develop these cognitive processes, how do you expose them, and how the cognitive reasoning becomes a part of this? So these services you are building are essentially a part of these cognitive services, where you go from perception to abstraction to metacognition, right? That's the multiple layer part of that. And if you have that layered cognition available, how do you apply hierarchical generalization on top of that? How you build feedback-driven refinement on top of that? So essentially, you can think of a cognitive services as a set of principles or stacked intelligence in which you can learn, you can reason, and you can self-improve on a progressively higher level of understanding. It brings up a very interesting topic around AGI and ASI and a variety of other areas. But to more talk about what enterprises are today using in terms of cognitive services, essentially the services which allow you to do everyday business jobs. So think about OCR. like a simple cognitive services, which is often exposed by Microsoft as for document intelligence, which understands a document, handwritten document, give you very high accuracy based results, does entity recognition. So these are cognitive services which are very tactical and take the tacit knowledge we have about how human reasoning evolves from perception to abstraction to metacognition, and then exposes it for a larger workflow. So you can integrate it as a part of a workflow, and then it becomes, as a part of your enterprise cognition around metacognition brain of an enterprise. Yeah. So it provides those capabilities. So it can apply to the entire organization, variety of different formats, whether it's vision, whether it's audio, whether it's text analysis, whether even as a decision management, right? Decision management based services, which can actually take your knowledge graph of a variety of different possibilities and then apply that to build comprehensive decision points with specific probabilities. That would be the way to go.
Awesome. Again, I appreciate you doing a little hand holding here and just walking through our audience a bit, but very important that we know these terms. I'm going to want to go, into a few of the examples of how, you've developed some of these systems in healthcare and finance, and then ultimately we'll loop into the quantum theme in a little bit. But before we even do any of that, could you take a couple of minutes, Adnan, and just talk about UST? Because I introduced the company as a global digital transformation solutions company. You're one of these companies that's it's no joke in terms. You got tens of thousands of employees all around the world. It's a name that is everywhere, but we don't hear about. You're quietly in the back scene, sort of doing a lot of things and many different clients of all different industries. Take a couple minutes just to introduce who UST is today in 2025 and a little bit about the general business model.
Sure. So I'll start with who UST is, or what our ethos is, and who we as a company are. So UST is a digital transformation company. So at our core, we are a very customer-centric, customer-focused, hyper-customer focused company, right? We are a digital technology services company, which is focused on delivering strategic transformation outcomes for enterprises. Like that's kind of like a vision or a byline part of it. But if you do a deep dive on it, we have capabilities in consulting, IT services, software engineering, data AI, and industry-specific solutions. Like these are the different areas. We also have capabilities within silicon development. So we do actual chip manufacturing, and it's a US-based company built in California. Our major offshoring and various development activities are all over the world. So we have in Europe and Australia and India and western part of Western Europe and Eastern Europe, as well as, of course, United States. So United States is one of our largest presence. We work with majority of the Fortune 100 companies here. Major three areas I want to say we focus on is retail, healthcare, and finance. So finance, healthcare, and retail, these are the main three areas we mainly focus on when it comes to any kind of, especially with the payer space. So healthcare payer space is one of our major focus, financial services as well, and retail, all the major retailers you can imagine on Fortune 100 list, majority of them are our clients. I think one of the core things we bring to the table is being hyper customer focused. So instead of having not like too many clients, but rather focus on our clients. So digital transformation for the clients, whether it's AI, cybersecurity, platform, cloud modernization, industry specific solutions, all of that we build for the enterprise. It was founded in 1999. Now we have about 35,000 plus employees, 30 plus countries and deliverable. And manufacturing is another one of the vertical we focus on. So I guess healthcare, financial services, manufacturing, retail, public sector. So yeah, that giving back to the community is a big theme as part of UST. So we have a program called Step It Up, and that program essentially trains the veterans and the minorities and people who can't afford these trainings to actually train them in IT, digital transformation services, and then bring them into the mainstream development. So we place them in various areas. And it's a very successful program, been going on for almost a decade now. And it was one of the recent, actually, when Biden was vice president, he came to one of our event and actually announced it. That video you can probably find online, where it was announced that how it is helping, the program is helping veterans, and it's a program which is ongoing, and we are quite proud of it because of the mentorship and how it changes the life of a lot of people because of giving them the tool they need. And I've been involved in several of these trainings, and I found that to be very meaningful, especially the employment part, and then being able to give back to the community.
It's interesting though, before you took on this current role of chief artificial intelligence architect, I mean, you were for many years really in the trenches, developing these cognitive systems for healthcare, for finance, for big manufacturers. And I thought it'd be interesting, just looking at a couple of these examples to sort of get your vision as we, in 2025, we're on the cusp of 2026 and sort of where we are in some of these niches. And then as I said, a little later on, we'll pull quantum into this and get your view there. But if we just look at something like healthcare, and you wrote a couple of pieces recently on your Medium blog in terms of use cases in intelligent care, from diagnostics to drug discovery, and then into the payer space, of course. And you were talking about fraud before. I thought one of the most interesting things in one of your papers, you talk about fatigue, clinician fatigue, which is a topic that we actually brought up with James Madara from the American Medical Association a couple of months ago. Something we don't think much about, that, hey, we think a lot about the patients and we think about the product, but we always think about the clinician and, how they're getting burnt out nowadays with all these activities that good cognitive services help improve. Take us a little bit down that path of, I know you worked with a lot of the insurance companies. What are some of your visions in this space as we get into 2026?
Yeah, so that's a fairly wide question, Ira. I think all of these industries, I'll talk about more current aspects of how we are seeing in the industry right now being completely revamped or being disrupted with generative AI and AI. And we are seeing that constantly being happening internally with application of AI and generative AI in the space of healthcare, finance, retail, all three of them, these areas. And it's very fascinating to see how AI and generative AI and agentic AI is changing the landscape of how we see these industries and their use cases. So I'll talk about, just like in terms of clinician fatigue, you talked about how AI is now augmenting and helping physicians and clinicians to be able to work with them. So it's not necessarily the whole notion of AI is coming to take your job, it's rather to augment you as to do this work more effectively, and how it can help you with understanding and applying the tools and technologies you're very familiar with, but rather helping you to grow that at scale, to be able to allow you to utilize that more effectively. So a general example is, instead of giving you a specific client example, is I work very closely with MIT and Stanford, and they both have very great health facilities associated with them. Mm-hmm. And they work with several hospitals, and of course, Stanford Center for Health. We actually started a Stanford Center for Health with AI, with Stanford AI Lab, which is now a part of HAI. And in that, one of the very common use case, this is for call center folks, is when they would get tons of calls, this is for payer space, they will get tons of calls from their from the customers. And they were supposed to, answer questions from PDFs and from different documents, and they have to search for it and get this information out. Now, it's a fairly low-hanging fruit, and you'll see a lot of these examples similar to that. But in our case, we were able to extract this information out, meaningful, grounded, non-hallucinated, actual real information out of these thousands of PDF documents to make the life of these people easier. But not just that, also they reduce the time in that case, compress the time, give quality output, so improve the quality of the output which is being provided to these individuals, but also on top of that, give them the tools to be able to enter this information as action item for later use. So for instance, if you are calling and you're asking for some incident which you had, I will be able to give you the right information which you're looking for from these thousands of documents by using AI. But then what is needed to happen next, I can also do that. So think of it as a co-pilot, but this is pre-co-pilot era. So we did it like much before that. So these things have now become much more mainstream. So you are seeing more and more involvement in that. But this really what's happening, we are seeing in the industry right now is augmentation of human potential as part of artificial intelligence. So AI is now being integrated as part of your workflow. Clinician workflow, I brought up MIT and Stanford. One of the things we are seeing is, especially in the radiologist space, where how AI is completely embedded with part of the radiology. And I think one of the earlier podcasts I was listening to was yet a physician, and you guys were having a discussion on like how it can impact your entire workflow. So in this case, if you were presented with a specific diagnosis, or you're presented with a specific finding from a specific X-ray or a medical imaging, you can actually have AI confirm it, look further into it, augment what was finding, and then have the expert make the decision on top of it. But that AI can really help you being that augmentation tool and help you. And that's something which we have done in both, of course, in healthcare, but also in manufacturing, where there's a lot of computer vision related things. One of the, I mean, it's so very now has become a part and participle of the things you build is separation of good lemons from bad lemons, right? Mm-hmm. So figuring that out, like it's now become a part of this value chain, which we now take for granted, right? So mm-hmm. AI is processing these supply chain with 2,500, 3,000 of these getting processed within a minute over the chain in multiple different streams, and you have a really good algorithm, YOLO 8 or other algorithms running through and doing getting a precision and recall for over 98% to separate out good from bad for merchandises, mm-hmm. for fruits, for other things. So it's just it's really fascinating to see the real world implementation of it, and it kind of dispels this whole doomsday. Right. Whenever, that right of like how applicable and how meaningful it is to take people from these mundane tasks of which don't really scale, and nobody wakes up in the morning and says, I'm now going to go ahead and separate out all the moldy lemons from the good lemons. Right. And that's how I want to spend my day doing, right? So this is this really makes you feel valuable when you build these systems to help them do these things, which I think are essentially a waste of time for humans for a lot of cases. Yeah.
And along the lines of, you're mentioning human collaboration with AI, clearly another piece, of your work, and I know you published a bit on so-called cognitive robotics and process automation. Could you say a couple words about that? Because obviously, in sort of the, as you're just mentioning, the fear about AI is going to be doing all this stuff. Oh, a lot of robots happening now, and can you say a couple words about what cognitive robotics processing is all about, and sort of how that fits into sort of your portfolio, and we think about that?
Yeah, no, absolutely. I think we can connect it back to what we were talking about earlier in terms of robotics, right? So AI guided navigation in robotics and surgery, precision assistance in robotics, motion planning. These are some of the things which are very relevant to how you achieve operational efficiency. You have talked about, I think what we are talking about here is the soft robotics and migrating to the hard robotics part of it. Yep. So think of in terms of like, say, diagnostic and imaging, we have talked about that, right? So AI-assisted radiology, AI-assisted pathology, ophthalmology, early cancer anomaly detection. What tools and technologies can be used to automate that workflow? That's something which I think, when I think of soft robotics, that's what I'm thinking about, right? There is also a clinical documentation, something we talked about, ambient scoring and transcription and EHR summarization, coding automation, things like that. So those are some of the things which are heavily AI related for operational efficiency. And then we move more towards, I guess there's a spectrum of soft robotics to hard robotics, as in like moving machines. So you have virtual care and chatbots, which do symptom triage, mental health assistance, chronic disease coaching, things like that, which are like, like soft robotics things, and things which are helping you doing medical image reconstruction, where, MRI enhancements or CT enhancements, denoising, we spoke about like how it can augment a person's view of a physician's view of how he's applying things. Another area where we work very closely on with, especially with payers, is around claims and fraud detection. So insurance anomaly detection and outlier analysis, billing integrity audits. But these are all what I call the soft robotics or software-driven robots. What you're essentially talking about is something more around, I guess, robotics and being used in a cognitive sense. So like Atlas, maybe one of those. Yeah. So in that case, I think there's also a middle ground around robotics process automation, right? So we have the RPA part of the things, which is again the soft robotics things, where you're talking about like document processing, email automation, data entry, and migration, customer support, finance and accounting. So these are a variety of the things in operations, how we take HR operations, onboarding, payroll, leave processing, and apply soft robots to this. Now, this actually has whole thing has changed since the advent of agentic AI. So I was trying to bring this whole around agentic AI. And the reason I want to say that is because the traditional RPA we used to have, how we used to approach RPA, robotics process automation, has wildly changed since the advent of agentic AI. And what's so different about agentic AI is that it's the goal-driven automation. So what I mean by that is, like, previously you have to tell, hey, go to this form, find this text, enter this information, and do X, right? That has completely gone. Now you essentially define, like, fill out this form for me and do this, or write this code for me and build this application, or triage this bunch of emails for me, and don't have to actually define that. So the part of the planning, which used to be one of the most time-consuming and painful part, whether it's claim education or prior authorization or EHR or inventory update, whatever you think would happen in the behind the scenes, is now becoming so much streamlined with LLM as the brain of these agents, that it is just making it really robust and fast, and it works quite effectively. And that's, I think, which has completely, if not transformed the way RPA works. So traditional RPA companies are completely migrating now to use LLMs to start robotics process automation, and then that's what's happening in the new world. Now apply that to the hard robotics. Right. So when you talk about hard robotics, we're talking about autonomous navigation, you're talking about Teslas, you're talking about autonomous driving, computer vision, human-robot interaction, reinforcement learning, especially, right? Healthcare robotics, industrial automation. Now that's the moving robots. That's the MIT Media Lab has a lot of that. MIT Robotics Lab has a lot of work in that space. There's this researcher who's the head of MIT CSAIL, and she, Danielle Russ, and she usually is very focused on robots being only the ones which actually move. Right? She doesn't consider soft robots as robots, but in that space, of course, we are seeing a lot of changes, specifically now because with LLMs, now you have this capability to understand the world much more effectively than just path planning by brute force. You can understand the environment so more effectively. You probably have seen the Neo, the new bot, which everybody's. So how does it interact with the world? The world modeling has changed. Before how we used to do autonomous navigation around the place, how the object detection, pose estimation, defect inspection, facial recognition, all of this used to happen, but with reinforcement learning being at the front and center, and now that has been modifying into more adaptive motion control, manipulation, real-time optimization, using LLMs as your middle man in the middle, which is trying to. It has a very good knowledge of the world already. So how can you utilize that knowledge in real time to get that? The biggest challenge then again comes down to latency. So how much latency is tolerable, especially in real world automation? It's not that easy to have that level of latency. So SLMs can come into play very well. But SLM, again, the knowledge distillation is a challenge, and how you run these things on the edge more effectively, which are not so power hungry, because you don't want your robot to die in like 2 minutes if there's a H100 GPU running in there, right? So then the whole thing will be just a giant battery pack. So how would you make that happen where it's actually interacting with the physical world, right? So collective behavior for exploration, delivery, search operations, swarm robotics, for example, which can get used if you're using for reconnaissance, bomb disposal, surveillance, things like that. How would the interaction with the world? So these are very, very interesting problems we are dealing with right now, especially from robotics perspective. And we are seeing a lot of development in that space, especially happening with agents and LLMs being the brain of these robots.
Yep, absolutely. And it must be, I want to get to, bring quantum in here in a couple of minutes, but before we do that, we talked a little about UST and the business model previously. I was wondering if you could say a couple words about your role today as chief architect of AI and ML at UST, because you're talking about the important collaborations and for Stanford and MIT and all that. That's just one small part of what you do, and clearly a major part is you got 30 some odd thousand employees, and thinking about the workforce, upskilling it, not just AI ML, but thinking how we're going to be doing quantum and everything else that's coming down the pike. What's sort of the day-to-day role of a chief architect? Someone in your position, what do you do on a daily basis, and what are the types of things you have to think about in terms of how the technology, both software and hardware, is developing?
Right. So my role is part strategic and part tactical, and I like it that way because then I can keep at the level where people are operating, but also at strategic thinking when you can apply thought leadership in that space. And that's why I have one of my foot in academia and other in the industry. So I was a visiting scholar at Stanford University. I do publications and patents and other things along with both at Stanford and MIT, but I also work very closely with customers and C-suite to ensure that our offerings, our capabilities, and what UST has as its accelerators and products and services is cutting edge. It has differentiation, and it actually is a research grade production implementation. So our customers get the best of both worlds. What I do on a day-to-day basis is essentially bringing all of this knowledge from academia and from industry to our clients. Like, that's the main thing. So I talk to C-suites. Nowadays, discussions are very much focused around how can they implement LLMs in operationalizing their operations within their systems. So, for example, if you are working for healthcare, a simple case could be natural language to SQL analytics. How can I create self-service insights over claims? How can I create guardrails around using, let's say, BigQuery across with our back and auditing? So these conversations are very multifaceted because you're talking to the C-suite, you're talking about the ROI, the KPIs, how this is specific, like not building technology for the sake of technology, but rather what impact can it bring? Like what are the KPIs you're implementing in terms of efficiency? What ROI is going to come out of that? Like what percentage of impact we will be able to create? Like 18% first pass approvals, 20% avoidable denials. We have rules for these policies check we can implement. And so this is a completely different language you would use to communicate this with the board members and other folks who are in management and leadership positions when they are trying to understand this. And that really helps me ground myself to understand what are the priorities for the businesses. Because technology for the sake of technology, being a nerd, I think it goes a long way. But when it comes to businesses, as you know, it's very important for them to look at what value a business can provide to its shareholders. Right. And that's shareholders includes their customers, their providers, the board members, and the wider public as well. So those are the things I usually talk about, invest my time in learning about, and then providing a point of view, which is based on evidence, which is based on the market reality, and also based on the implementations we have done. It's such a new space that nobody is going to come around and then say, I have 10 years experience in generative AI and 12-year experience in writing LLM work, and I've done context engineering for past 5 years. Like it's an evolving world where we are seeing how we can use LLMs more effectively, reduce the cost, do planning, build agentic AI where we have guardrails in place, think about like prior auth triage and denial prediction. That's a very important use case. How can I use RAG in this space for policy check? How can I prioritize the queue for these prior auths? How can I improve the impact, right? Banking and wealth management, that's a big area we work on. So when business is talking to us, we're talking about like how can we apply AI to KYC, know your customer? How can LLM summarization can help an agent to give information with evidence, with links, with actual a knowledge graph, which says that this fraud has happened in this location because, and not just show a bunch of graphs, like a bunch of numbers on this. So entity resolution, analyst review time reduction, SLA breaches, how would we reduce that? So those are the things where most of the time is spent, like how you take technology and then translate it to real impact. So capital markets, right? Trade surveillance copilot is going on all over the place. So you look at the patterns, you look at explainable alerts, and explainability becomes a very important part of it. But explainability differs between different stakeholders. So you have explainability when it comes to transparency of algorithm, but also is explainability when it comes to counterfactuals or SHAP or LIME or a variety of different techniques we use to actually explain different algorithms to different stakeholders in different level of details. So those are the kind of discussions which I am a part of on my day-to-day operations and communicate like how would we achieve that, what are the industry best practices or what are we seeing in the industry, and how can we improve upon these things, whether it's in manufacturing or supply chain or insurance or utilities. Telecom is a big sector we work with, public sector implementations. These are just like some of the examples, but it's a great place to work. I really enjoy it because then I get to, and with my team, of course, it's not a one-person thing. We have experts in each one of these domains where we work with business stakeholders, and these team members help me build that foundation on which we can then really deliver value to our customers.
Excellent. And I think this is a great time to segue into quantum. And as you've pointed out quite elegantly earlier on, just like humans and AI or humans robotics are not competitors, they're very complementary. I think we're going to be able to say the same thing about quantum computing, and obviously AI is a great way for making our machines think differently, and quantum is a way to make them compute differently, which two different things that come together very nicely. Before we get into some of your thinking about sort of applications again across these different areas and how you ultimately think about taking care of your clients, whether it's going to be healthcare, finance, whatever, you wrote a very interesting piece just a couple of months ago. It's entitled "Learning Roadmap for Software Developers Entering the Field of Quantum Computation," where you a very comprehensive roadmap to sort of, sort of the short point, we got to get into quantum, and we got to learn quantum because this is a major part of our future. And you talked a little bit about yourself and sort of, I had to re-immerse myself and learn this stuff because it's coming fast and furious, and as we point out, a lot of the devices are getting developed as we're speaking right now. Talk a little about your own. I mean, how did you personally immerse yourself and teach yourself quantum recently, and then we'll go into a little of how you're thinking about it at UST.
Right, no, thank you. I think it makes a really good segue. So just like artificial intelligence, quantum is something which is, artificial intelligence now has manifested itself into a force to be reckoned with. It's essentially a part of every implementation we do or happening in industry. I don't think any conversation around the table goes without discussion for AI. Quantum is not to that level at this point, and mainly because of we are still in the pre-quantum advantage era, where we are still trying to figure out whether there's quantum supremacy, there's quantum advantage, and every time we have seen the claims for quantum advantage. And just for the audience, quantum advantage means that we have computers which can perform better some task. Quantum computers can perform some tasks better than the triple computers. We find some nuance. Whenever somebody claims the quantum supremacy or quantum advantage, as you probably remember back like 2022, 2021, I was at this conference at MIT, and there was a quantum advantage, quantum supremacy announcement by a large hyperscaler, which shall remain unnamed. And there was a big rebuttal from a counter hyperscaler which said, no, there's no quantum efficiency being gained. And so this is constantly happening. We have famously seen the Majorana particle. So Majorana particle, the paper was taken back from Nature. It's published, and then it was a fairly, a sad moment when it was taken away. So we are, the thing is, like, when you talk to experts and the people who are in the industry about this, there is, of course, good news around how, because we are living in the NISQ era, right? NISQ, for the audience, it's the noisy era, which means the quantum, if you ask somebody, are we in the quantum advantage or quantum supremacy? Now we use the term quantum advantage, not say the supremacy. Supremacy, I guess, was too optimistic of a notion to say. The answer is always nuanced. So we don't have, essentially what I'm trying to say in so many words, we don't have a way of saying that now we have a quantum computer which works better than the classical supercomputers, right? And we have had publications around this, but every time it's not something which is meaningful in a business sense. Right. That has always been the challenge. So, but we know that if we get to a point where we are able to do these things much at scale, it's going to really change the fundamental paradigm of computing, of how we see computing done. Right. So instead of using classical bits, we now have superimposition, entanglement, interference. It's going to completely revamp the way we do cryptography, the drug discovery, the material sciences, optimization, AI model acceleration, right? Quantum simulation. There's all different areas where it's just going to really revolutionize that. So that's something I think is what brought me, was exciting to me. And I've been studying quantum computing for a while now. And so that was like always exciting part of this. But now I think moving forward to how I upskill myself, or if somebody who's listening, this podcast wants to learn about how do you upskill yourself, I think you have to first think about it in the fundamental part of the things. You don't have to become an expert in like physics and math, because I think it's famously said by Richard Feynman that nobody understands quantum mechanics really, which is very true, because it's a very I think it's a very, not just a tough subject, but it's very counterintuitive. So there's a lot of intuition we think we apply our knowledge to, but there's a lot of things in here are counterintuitive, and like Newtonian laws are not being applied. So it's just becomes very, like at a particle scale, this becomes very different. So in order to upskill yourselves, think about spending some time in foundational physics and math. If you can't understand it, there's a lot of accessible text, and you will probably post the link to my blog. And I have book reviews around quantum mechanics, probability theory, and entanglement, superimposition. So learn about these terms, what they really mean. What is superimposition? What is superposition? What is entanglement? How do you do measurement, right? There's Khan Academy has a really good linear algebra course we can take. MIT has this quantum physics course, which is really good. So by the way, quantum mechanics is very different than quantum computing. Well, I wouldn't say like very different, but one is fundamental science and the other one is a drive science. So quantum computing is drive based on applying quantum properties to computing. Right? That's what quantum computing is. And quantum mechanics is the fundamental properties of nature. So they already exist. So that's now to upskill. If you have gotten hold of some of the fundamental ideas, then you can start looking into quantum programming. And if you look at Microsoft's Q Sharp, or IBM's Qiskit, or Google's Cirq, these are the programming languages. AWS has Bracket, and there's CUDA-Q by NVIDIA. I found that from an ecosystem perspective, Qiskit is the most popular one. Everybody has used Qiskit. Everybody has in the sense the industry, people are very well aware of it. There's a large ecosystem, because you want to work with something which is a large ecosystem. You can find samples, you can find tutorials, you can find books. So IBM Qiskit is one of the best tools to get started for people. I personally like Q Sharp as in C Sharp. It's a Microsoft ecosystem product. It's a really good tool to get started. But just from an ecosystem, purely from ecosystem perspective, Qiskit is fairly a big presence in the market. Now you can use that. There's a lot of tutorials out there, so you can start learning about like, how can I flip a gate? What is really a gate in quantum? right? So now we always talk about bits. Now there's qubits. How do I flip a qubit? How do I operate on a qubit? How do I simulate an entanglement in a qubit? What kind of gates would I use to do with and you start essentially using quantum simulators to start testing around, right? There's actually mobile applications for Qiskit where you can play around with quantum simulators, and they give you a good overview of what these are. You can study quantum gates. You can say like block sphere, measurement theory, decoherence, quantum error correction, some of the major concepts around like, why do we need quantum error correction? Why is this a time frame for decoherence of a qubit is so small, right? Then it brings to you like, oh, so the qubit is essentially, it's very hard to keep it in the state it is to perform any operation. So because it has elements from all over the place which are impacting it, and it gives you an appreciation for how hard this problem is really and why it is taking so long for people to apply. So once you are done with the physics part of it and picking up a framework and understanding some of the framework related things, then you can start looking into more complex things like quantum algorithms. You can look at like Jozsa, Grover, Shor, VQE, a bunch of other algorithms around this. So I'll start with problem like Shor. So I actually met Peter Shor at MIT.
Okay.
You know Shor's algorithm, the famous Shor's algorithm, right? I'll send you the photo if you might want to put it on. That's considered my celebrity sighting. Like I was so happy to see him. I'm like, wow, this is one of the brilliant minds who have come up with this algorithm, which everybody studies and works with when they're talking about the quantum computing. And then think about like, how can you apply that to optimization? Chemistry and finance problems. Like if you take that, and that's actually, as soon as you start applying those algorithms, it causes this mental shift from a traditional Turing style thinking to the quantum style thinking, right? So that's I think, which takes a very long time to do. Honestly, it's the counterintuitive part of this. You explore Qiskit runtime or Penny Lane or TensorFlow Quantum or QRQ, whichever library you choose. You can, of course, always test with quantum simulators. You can actually get time on real quantum machines as well. But for all intents and purposes, when you're starting to experiment, then it's good enough for you to work with that. Now that you have done all of this, which I've talked about, I think the next step is to look into a specific part of, like, say, quantum machine learning, or look at the so quantum ML is a great tool to explore like where it actually provides value in machine learning, if that's something you want to do. And if you want to go with formal certification and program, you can go with IBM has a quantum developer certification. I have taken some of those, and they are all part of my profile. I'm sure was probably shared earlier. Qiskit has a global summer school. Stanford has a really, really good course, which I've taken, and it goes into a very immersive details of quantum mechanics. I mean, it goes into like harmonics of this, the actual physical constructs, a lot of math involved in that. So that's also, if you're interested in that kind of thing, then it might be good to also look at the Reddit. Quantum Open Source Foundation is there. IBM Quantum has tons of things. And trust me, I mean, in Reddit and in the quantum forums I've seen, any question you have, it comes to your mind, there's an answer for that. Archive for quantum physics is great. Starting to read quantum physics paper is a bit hard if you're just starting out, but there are a couple of papers which are like, for example, one is on quantum machine learning. I've published a post about it, and there's another one on quantum tutorials. I've blogged about that as well. So they help you understand the concept. And you don't have to be really, honestly, a quantum master before you start, exploring these things. You can't be like, oh, I don't know enough math, so I cannot code quantum computing algorithms, or I cannot explore how it can apply to industry domains. Because we need people who know quantum in all different walks of life. We need people who do community and research. We also need people who do software development for quantum applications. We also need people who do practical integration, right? Mapping the quantum solutions to industry domains like drug design, logistics, portfolio optimization, cybersecurity. Who's going to create this classical quantum compute pipelines? Because one thing I think the listeners should know, that the quantum computers are not going to be your gaming engines, right? And you're not going to play Roblox and Minecraft and on quantum computers, there will be a quantum classical hybrid pipeline, which will be built, which will be, there are certain things which classical computers are doing great, and they will continue doing that. And there are certain things which quantum computers will do great, and then they'll do great. But there will be a hybrid, which that pipeline will be implemented to combine the best of the worlds together. And that's where we need people to actually do that. So that's my quick take on the upskilling. I hope that kind of helps as to like what I think may work, but everybody has their own path. So it might change. It might take 6 months. It may take 3 months. Some people can do it faster.
Yeah. No, it's important, and yeah, again, we will obviously be linking to your blog and specifically to that paper because I think it's extremely important. But thinking about if the post NISQ era arrives tomorrow and we have perfectly fault tolerant quantum computing in front of us, and then are there problems that you would like first to feed into the system when it gets here? I mean, obviously, everything you've done in terms of healthcare and finance and manufacturing and the systems you've been on the AI front, you solved a lot of problems. Any specific problems, whether they're complex pricing derivatives or anything like that? You're like, hey, that might be a good first use of this thing. I'm not going to play Roblox, but maybe I could do X, Y, and Z. But what do you dream about? Let's say, bring your first couple things you want to play around with once it's here formally.
Yeah, that's very interesting, right? So, what are the great use cases for quantum, or would be the top use case for the quantum? Would be, I think, one of the things which we are scared of in cryptography, so that we call it post-quantum cryptography. So I think you're probably aware of when people have downloaded, adversaries have downloaded tons of information from different places, and now they're just waiting for quantum computers to become available so they can decrypt them, right? So harvesting of this information where it's all encrypted, and once it happens, they will start decrypting those. So that would be really bad time. And we have national guidance around this. I've written about it as well as to like what the post-quantum cryptography is going to change and how we can, Shor's algorithm has proven to threaten RSA. So we know that, RSA is not secure because of that. We can easily factor things out. So just to make it very simple, our current public key cryptography architecture, in very simple terms, based on very large numbers. And these large numbers are product of primes. So in order to find out these keys, one is a private key and another public key. I'm making it really simple. These are the product of two primes. So imagine a prime being 5 and a 3. So if I tell you the number is 15, it's very easy to know that it's a product of 5 and a 3. They are both prime numbers. But if I give you a really, really long number, to factor it out, you need to actually know at least one of the prime numbers. And finding out that prime is so hard because you cannot divide by 3, or you can't. It's not easily findable until you actually find one of the primes. Then you can find the other prime. But if you have to find at least one of the prime, and because that's the entire, think of it as like entire cryptography is necessarily foundational. Now, with what Shor's algorithm has proven, and the quantum computers, if we have sufficiently strong quantum computer available, then we will be able to find that prime like that, right, really quickly. Not like that, but very quickly, as compared to where we are. And that breaks our current cryptography. So I think one of the most alarming and most effective applications of this will be the cryptography. And that's where we are working on post-quantum cryptography. It has become essential, and it applies that, right? But when it comes to, I think, usability of that, the simulation of molecules, protein folding, reaction pathways beyond what we have in classical limit is really the best use case for humanity I can imagine. Now you have drug discovery and chemistry where you can simulate like how the reaction pathway will look like for this specific medicine or entire human genome. Like, wow, you can actually do that now, right? That's just fascinating. I think that's going to open up so many new pathways for new, more effective drugs, which are personalized medicine for individuals. And I think that would be one of the most beneficial thing for humanity in general if we get that to work. The other ones I can think of is material sciences, like designing
Right.
superconductors, catalysts, batteries with quantum simulation. So now you can actually simulate to the level at so low that you can actually see what the material will do in different conditions, in different temperatures and different pressures and stress and all those different scenarios, and including batteries, which will really help us build that. And a combination of AI and quantum will really help us build these new materials much more effectively. Optimization, of course, you talked about the stock market part of the thing. So portfolio optimization, logistic routing, supply chain, energy grid up balancing. Those are, of course, one of the textbook use cases for that. Finance has risk modeling, option pricing, Monte Carlo acceleration, arbitrage. All of these things are very much on the table for that. I think another one of the use case I can think of which will be very important is climate and energy.
Okay.
So simulation for carbon capture materials, fusion design, grid development, right? These are some of the important areas for that. Cybersecurity, of course, we talked about there, and AI and quantum hybrid is another one of the cases where but the most I'm excited about is drug discovery and chemistry. I think those will be really beneficial.
Yeah. Yeah, I have a lot of pharma guests on, and they're all extremely excited about that. But I'm glad you brought up the part about material sciences, because we did just profile the General Atomics, tokamak work, and we think about sort of the energy part of that, but the material science component of that is so crucial in making ultimately fusion a reality, just like quantum a reality. And yeah, I mean it's an exciting coming few years, and you're going to be right at the middle of all of it. So it's it's really an amazing set of work, and I take my hat off to you and your team. I mean, it's an amazing group that you have there thinking about these, and then obviously staying on the bleeding edge of things as they continue to develop. And anything else? What else is happening as we get into 2026 that we should know about? I mean, well, again, we'll point people to your blog, and obviously you write about everything there that we're talking about today and more on sort of futurism and where all this is going. But conferences, talks, other public-facing initiatives that are coming up as we get to the end of 2025 into 2026, and then anything else that I missed that you might want to talk about, please.
No, I think you have covered a lot in this short time, and we have seen recently, I think the most exciting news has been, which came out of Google recently, about a quantum advantage. You have seen that paper probably, right. And that claim. So we'll see about that, like how effective that the claim is, and what are the real true ramification of that would be. I think we are all trying to accelerate toward go from NISQ to post-NISQ era. So right now, so NISQ, we keep using this term without defining it. So NISQ stands for noisy intermediate scale quantum. That's the word we are, and so think of it as a noisy, N for noisy, where we are in a 50 to 1,000 qubit era right now. They're noisy, they're error prone, they have limited coherence, which means you cannot use that bit for a long period of time. The noise and decoherence is very small. The quantum state collapses very quickly, which means you have to have multiple qubits to back up the original qubit, the state of that, right? So you have to have error correction, which becomes really resource intensive for today's qubit count, right? So even if you have, let's say, 1,000 qubit, you may have, 100,000 qubits to actually be able to have those qubits in fidelity, right? So scale is hard to maintain for that. Benchmarking becomes hard because then you can't really measure a real quantum advantage if you do this. So these are some of the challenges we see right now in hybrid quantum. And I don't want to paint a rosy picture around this because these are some of the challenges. And I think some of the quantum enthusiasts, I'm a big quantum believer, but at the same time, I'm not going to say that we are going to overcome these problems right away, because we have seen a lot of setbacks in the industry. We don't openly, I guess, hear about that a lot, but Mariana gates were a big setback in that day. So in post-NISQ era, let's just say tomorrow we have found out, like, how can we have a large-scale error-corrected system? They are like, fault-tolerant quantum, as we call them. Millions of physical qubits per logical qubit we are available. We have fault tolerant platform. Now we have, multiple different technologies competing. So superconducting, qubit, ionic, photonic, like these are three major. Majorana is another one, but it's not because it's not real yet. So we are thinking about superconducting, qubit, ions, or photonic, and a standardization based on that, right? So we'll see that. We'll also see like the other problems around physics. We are trying to scale, like cryogenic scaling, power overhead associated with that. People are talking about how space is a great place for having a quantum data center, right? That's because we have 1 Kelvin in there, so it's great. It's very cold, but also there's a shortage of quantum engineers, like limited development frameworks. So if you think about computers, like since inception, like billions of dollars have been spent on that. Even like orders of magnitude amount has been less amount has been spent on quantum, right? So quantum experimentation to quantum utility to quantum advantage at industrial scale requires a significant amount of investment and growth in a lot of different areas, right? So what I see next in quantum, I think reliable logical qubits, that's where industry is trying to get to, and everybody is trying to get to. And Nature recently had a paper about how you can have larger logical memories, error correction, more stable logical qubits. That's what we are seeing. We are seeing this neutral atom scaling, where 6,000 plus qubit arrays, and now you have algorithmic fault tolerance, which can maybe lead us to useful sizes. That's still something in experimentation phase. So again, with the roadmap, we see IBM, Google both are pushing towards fault tolerant stacks. So multi-chip processors, building couplers, QEC prototypes. So that's all are happening. But I think industry integration will be an important factor, where you have GPUs and quantum computing co-design. So NVIDIA Lab is working with the MIT and Harvard both for with Quantanium and QERA as well to build that, right? It's GPU plus QC. So next year, and like you're talking about how the roadmap looks like, this is something which we'll see more. There's also PQC will happen in industry, post-quantum cryptography. The rollout of that is already happening. There's already guidelines from federal government around NIST FIPS. The NIST has the FIPS 203, 204, 205 finalized. So enterprises now are migrating the cryptography to Kyber and Lithium and Sphinx, these standards. So these are the post-quantum cryptography rollouts which are coming to play. So you will see in next year and so on, people are going to start migrating to post-quantum cryptography, where it's not as easily breakable in the quantum world as well. So these are some of the, I guess, things you will see, unless we come up with a new quantum technology which works amazingly well. Yeah. I think we are waiting for the ChatGPT moment for quantum computing.
Well, we'll hold off on going to post-quantum. That'll be for another episode, but it'll be interesting to tap your brain to see where we're going after this. But yeah, I mean, you clearly have quite a bit in the portfolio. It's going to be an exciting several years as these various technologies evolve and mature and ultimately fit into your strategy there of taking them from research and ultimately making these real world applications. But it's really exciting. It's an amazing journey that you've been on from where you started. Talking about interestingness and coming full circle here to quantum and post-quantum cryptography and all that. But I'm excited for you. I mean, really wishing you and your team the best as you continue to develop these systems. And again, for everybody out there that's going to be listening to this episode across the various podcast networks, or who will be watching on YouTube. Again, you've been spending time with Dr. Adnan Masood, Chief Artificial Intelligence Architect at UST, doing really amazing work at the intersections of artificial intelligence, quantum computing, evolving innovations, ultimately all to bring real world applications to businesses. Adnan, I really want to thank you for taking the time to educate us on a lot of very interesting topics that we don't normally get into. Obviously, thank you for everything you do in the area of STEM. And as we like to say on our show, thanks for helping to create a better tomorrow for so many people via the way you design these systems and ultimately make them applicable in all our lives. Really an awesome story. And I look forward to continue to follow you and hopefully doing a follow-up down the road on what comes next.
Thank you very much. I appreciate you having me on the show here. One last thing, I think, so if you have time to talk really about the
Absolutely.
2025 Nobel Prize in Physics, which was our
Oh yeah.
major thing, right? So essentially, it was given about to the Nobel laureates about essentially how they demonstrated how quantum mechanical effects can appear in macroscopic electrical circuits.
Right.
So when we talk typically about quantum, we are always talking about subatomic level. We're talking about how these things happen in subatomic level. And I highly encourage people to look into quantum computing and how the quantum bits, qubits, work with superposition, which is both in the same state, how they're entangled or linked together, and how change in one affects the other one instantly, and how the interference, the results where you can get the correct results and cancel out the wrong happens. We can have a whole discussion around how this really works, but I just wanted to say that the Nobel Prize necessarily was about building superconducting circuits that exhibits this quantized energy level and quantum tunneling behavior large enough for everyday components, right? So it's a very accessible. By the way, the Nobel Committee, when they publish it, it's quite accessible and readable, even for a scientifically curious person. So they can go through and then see that how the work shows that quantum phenomena is not just confined to atoms and isolated particles, but it can be engineered in circuits and creates this foundation of quantum technology. And quantum phenomena is all around us, like from photosynthesis to our smells, the sense of smell.
Yeah.
It's very fascinating how it can be applied at a macro scale. So this is I found their work to be quite amazing applied for quantum computing.
Yeah, no, it's we've talked about quantum biology a bit on previous shows, and yeah, that's a nice little again connection there for even if you don't understand the paper on quantum decoherence and all that. Yeah, these examples in nature and photosynthesis and olfaction and all that are maybe something much more accessible into people's understanding. But I know I'm glad you linked it up that way. But yeah, that's really cool concept again. But yeah, really an awesome discussion. It was great having you.
Right. Good talking to you, Ara. Have a wonderful rest of your day, and thank you for your time.